Amulya from final year BTech Electronics and Telecommunication Department. I am presenting my presentation on memory map device interface coming under the course Computer Architecture. Let's start with our presentation. First one is Introduction to Memory Mapped Input Output Devices. Memory map interface is a method used to manage communication between the CPU and peripheral devices. In this method, device control registers are mapped to specific memory address, allowing the CPU to interact with hardware using standard memory instructions like load and store. Now let's talk about how memory map devices are accessed. In memory map IO, each hardware device is assigned to a portion of the computer's memory address space. The CPU accesses these devices by reading from and writing to the designated memory address, just as it do with regular RAM. This means peripheral devices such as hard drives, GPU, and network card can be controlled through memory operations. We can observe the same into picture shown where every bus is common to both memory and IO devices. Coming towards how memory map IO works. In memory map IO, each peripheral device is assigned specific memory addresses within the system address space. These addresses correspond to control and data register of the device, allowing the CPU to communicate with device through normal memory access command, example load and store. Shown diagram explain the same how input and output device such as keyboard, mouse are interfaced with CPU and memory. Talking about example of memory map devices, first one is frame buffers. These devices have memory that can be directly accessed by users thread through memory mapping. Second one is Commodore 64. This device uses memory mapping to make RAM or IO hardware appear in the following ranges. Memory map buses are another example of memory map devices. A memory map bus extends the processor's memory address space to include the device on that bus. S bus and VME bus are the examples of memory map buses. Talking about advantages and challenges of memory map input IO. Advantages. First one is simplified architecture. With memory map IO, both memory and devices share the same address space, reducing the need for separate mechanism to handle device communication. Second one is efficient data transfer. Memory mapped IO allows for direct access to device without needing special IO instruction, resulting in more efficient data transfer, especially for high-speed devices. Third one is faster device access to DMA. Since devices are treated like memory location, the CPU can quickly read from and write to device register using direct memory addressing, improving performance in time critical application like real time systems. Fourth one is uniform performing model. Memory mapped IO allows these devices to be accessed using the same instruction that are used for reading and writing memory. This reduces the complexity of writing device drivers and makes it easy to manage device within the same memory access framework. Last one is cache benefit. Device that do not require frequent data update can be benefit from CPU's memory cache using memory mapped IO. This allows for faster access time to device register and status flag, reducing latency. Talking about challenges, first one is address space contention. One of the main challenge of memory map IO is the limited address space available. The more device mapped into memory, the less space there for system's RAM. Complexity in managing large scale system. In complex system within many peripherals, managing the address space and ensuring that devices do not overlap for interface with each other can be difficult. Third one is possible latency issues. Although memory map IO can offer fast access, certain memory map devices may not respond as quickly as expected, causing the CPU to wait longer than it would for memory. This may introduce latency issues in time sensitive application. Fourth one is efficient use of address space. In system with limited address space, example 32-bit system, a system portion of the addressable memory could be customized by devices, leaving less space for actual memory. This can limit the amount of RAM a system can use. Compatibility and portability issues. Not all hardware architecture or operating system support memory mapped I/O in same way. This can lead to compatibility problem when porting software across platform, especially between embedded system and general purpose system. Here are some of the application in modern system. First one is embedded system. Second is graphics processing unit. Third one is network interface card, and fourth is storage devices. Thank you for listening the presentation.